Good morning, students. Uh, I am Santosh Kumar, the max teacher Santosh Kumar speaking. Uh, now, we are going to solve some simple problems which are based on what properties of the determinants. Okay, simple problems. We are going to learn. Okay, so the problem number one: without expanding, you should not expand this determinants. Okay, I'm sorry, this you should not expand this determinant without expanding. By using the properties you have to solve, you need to prove this it is equal to 0. You have to prove. Okay, so how you see, just you recall all the properties. Okay, and one of the properties is, right, the last sixth property says by adding all the three rows, right, by adding all the three rows, that property, that is sixth property, which is, so this determinant I can write it as row 1 tends to row 1 plus row 2 plus row 3. All the three I'm going to add now. If I add, what is happening over here, you just see row 1, row 2, row 3, all the three I'm going to add and put it in row 1 itself, and I'm going to put it in row 1 itself. If I add, what will happen? This will become 0, this will become 0, this will become again 0. Correct? Because the minus a plus a will be getting cancelled, b minus b will be getting cancelled, and c minus c will be getting cancelled, 0. So like that, fully it will be 0. So before you see the problem, when you see the problem, what you have to do, first step is by adding all the rows or by adding all the columns, kindly check whether you get the same element. If you get the same element, then it is correct, you can do that step. Okay, so now the remaining two rows are as it is. You can write it b minus c and c minus a and a minus b and c minus a minus b, b minus c, right? Now you see one row is completely 0. That means value of the determinant is 0. That is actually one property. Second property, right? One row or one column is completely 0 means value of the determinant is 0. Okay, since by property you can put. Okay, that's it. You can write that property also. Since any one row is completely 0, then value of the determinant is 0, you can write. Fine, easy. Yeah, now we are seeing simple problems only. Later on we can increase the concepts, what to say, later on we can do the tough problem also. There is no tough problem, right? Some lengthy problem I'm saying. Okay, so now if you look at this problem, right, the value of this determinant they are asking. Okay, already I told you, by adding all the three rows or by adding all the three columns, if you get the same element, you can kindly proceed, I told you. Okay, now you can see, you can apply that method also, right? Or else you can do by different method. There are many methods to do find the value of this determinant. Okay, so one such method we are going to do now, that is row 1 and row 2, if you add, everywhere you get x plus y plus z, correct? Because by adding these three, x plus y plus z, so do it. So row 1 tends to row 1 plus row 2. If you do in this determinant, what will happen? Okay, so x plus y plus z, you will get x plus y plus z, correct? X plus y plus z, and you see one row is full of multiple of 3. Now you can take the 3 outside. Okay, so third row will become 1 1 1. I told you, common factor you can take it either from a row or column. That's a property, right? You would be seeing, you would have seen the properties, right? If you didn't understand this step, then you have to see the what are the properties. Okay, now middle row is as it is, z x y is as it is. Okay, now you see the first row itself, same elements, it's a common factor. You can write this is 1 into, Okay, this is also 1 into 1 into, that means that is also common. So if you take x plus y plus z again common by using property, what will happen? This will become 1 1 1, right? This is z, x, y, 1 1 1. Okay, now what you do, minus 3 x plus y plus z is as it is, you write, and then this value is 0. Y0 row 1 is identical, this is identical symbol, row 1 is identical to row 2, row 3. I mean, two rows are same, right? See, this as a property I didn't teach, but anyway you can take this as a property. Okay, because second step, if I do row 1 and row 2, if I subtract, what will happen? If I subtract two rows, it will become 0. One row is going to be 0, so obviously value of the determinant is 0. Okay, so or you can add this as a property also. Any two rows are same means value of the determinant will be 0. Okay, like that also. It is there in the NCERT also, but I didn't teach, but it is there in NCERT. Okay, otherwise you can any one row is completely 0 means value of the determinant is 0. Next step, what you have to do, subtract two rows, so value will be 0. Okay, so the entire answer is going to be 0. Okay, because this is 0, so entire answer is 0. Fine. So in the properties also you can add up one more statement, you can put seventh property you can put, and you can write, if two rows are identical, value of the determinant is 0, you can write. Okay, now this one, this is one important problem. Okay, because several times students are confused to answer this one, because the question will be, how they will ask is, prove that this determinant is 0 without expanding, like that they may ask. So if they ask like that without expanding, how you have to do is, right, we are going to see now. So the whole determinant, you take it as a determinant of a, okay, which is this one, 0 a minus b minus a 0 minus c. See, if you expand this determinant, the answer is going to be 0, but without expanding you have to prove. Okay, see what I'm going to do. From first row, minus you take common, second row again minus you take common, third row again minus you take common. Okay, now what will happen? This is going to be, first row I have taken minus common, 0 minus a b, all negative will become positive, positive will become negative, correct? So this is a 0 c, and this is minus b minus c 0, correct? Minus 1 into minus 1, it is minus, correct? And you see this one, this is what you know, it is A transpose, determinant of A transpose. What is determinant of A? This one, you find the transpose for this rows, you write it as column, this row write it as column, 0 a minus b, and then this row write it as column, minus a 0 minus c, this row write it as column, b c 0, correct? So what we got over here is determinant of A transpose, correct? Both are same, no? So this is determinant of A transpose, so you write determinant of A transpose for this one. Okay, this is determinant of A, correct? So determinant of A is equal to minus, right? And one more property, you know, determinant of A and determinant of A transpose, both are, yes, both are equal. Determinant of A and determinant of A transpose, both are equal. So this is also determinant of A, correct? So you can write this. So determinant of A is equal to minus determinant. So this minus determinant of A, bring it to this side, 2 times determinant of A equal to 0, which means determinant of A equal to 0. We proved it, because 2 times determinant of A is equal to 0 means 2 is not equal to, because product of two quantity is 0, so 2 is not equal to 0. Only determinant of A is 0, so determinant of A is equal to 0. That is nothing but proof. We proved it. This is what you have to prove, it is equal to 0. We proved it. That is what determinant A we have taken. Okay, you can take here that's it. Easy, simple question, very easy. Okay, we have to go by the proper way. If you learn by the proper way, everything is, max is going to be very easy, students. Okay, now can we do this sum? Okay, this we are going to see now. Prove that this is equal to A plus B plus C. I told you one trick in determinants. By adding all the rows or by adding all the columns, check whether you get the same element. Yes, I am getting here. How? By adding all the columns, you won't get the same element, because 2A plus 2A becomes 4A. 4A plus A is going to be 5A. But here 5B will come, here 5C will come. So we won't get the same element by adding all the columns. So by adding all the rows, you check it is going to be same now, because 2B plus 2B minus B will become B. 2C minus C is going to be plus C only. So you will get, everywhere you get A plus B plus C. So what I am saying here, left hand side, row 1 tends to row 1 plus row 2 plus row 3. If you do, you are first adding all the elements and putting in row 1 itself. So you get again A plus B plus C. Here also A plus B plus C. Here also A plus B plus C. And this is as it is, 2B. B minus C minus, these two rows are as it is. Okay, 2C, C minus A minus B. Okay, now you see one row fully same element, right? One row fully same element, right? So you can take the common elements outside. So if you take common elements outside, A plus B plus C, outside if I take 1 1 1, you get 2B, B minus C minus A, 2B, 2C, 2C, C minus A minus B. Again, another trick I'll tell you. If you see one particular row is full of numbers, particular row is full of numbers, means make 2 zeros and expand the determinant. Learn this once again. One particular row is full of numbers means make 2 zeros and expand the determinant. You will be able to prove it. Okay, so making 2 zeros, how to make this element? You can make it 0. How you know? It is present in C1. C1 tends to C1 minus C3 you do. Column 3 you keep it for calculation. Okay, similarly C2 tends to C2, this element you make 0. C2 tends to C2 minus C3 you can do. Okay, so if you do this one, what will happen is outside A plus B plus C is as it is. Okay, C1 and C3 we are subtracting, so it becomes 0 here, right? And C, these two we are subtracting, 2B and 2B. If you subtract, both will become 0. So it is going to be here 0. Again, C2 and C3 we are subtracting, right? Sorry, C1 and C3 we are subtracting. 2C and this one, both if you subtract this minus of that one, that means you will get here A plus B plus C you will get. Okay, similarly for second, C2 minus C3, that is this one, right? So that step, if you do, these two elements is going to be 0. No, this minus of that one, this element minus of that element will become minus B you will get. So it is minus of, you get minus of A plus B plus C. And here you see 2C minus, this is going to be 2C minus of that one is going to be A plus B plus C you will get. A plus B plus C you will get. So last row is as it is, last column is as it is, 1 2B 2b, and then c minus a minus b, c minus a minus b. Okay, so now what you do, a plus b plus c is as it is. Okay, see, now expand row 1, row 1 alone, expand row 1. So row 1 fully, if you expand, what will happen? In that only these two elements are 0, so leave these two elements, only one is valid. So open a bracket, 1 into 1 lies in this column and this row, so do cross multiplication, 0 minus, do this cross multiplication, it will be same element, no? So, and this way multiplication, already minus is there, one more minus is there, so it will become plus a plus b plus c the whole square. Okay, kindly listen, this element lies in this column and this row, so do cross multiplication, 2 cross 2, determinant is this one, right? So this into this one is 0, and this into this one minus of, right, minus of these two, multiplication, already minus is there, one more minus over here, correct? So it will become plus. Now if you multiply these two, you will get a plus b plus c the whole cube, because this is 0, 1 into this one is as it is, then this into this is going to be a plus b plus c the whole cube. So we proved it, hence proved. Okay, very easy, students, right? Few more problems also we will see, right? In short duration, whatever is possible I am doing. Okay, so in case of any mistakes, right, you can please consider, right, because I am not having textbook also, right? One just now we have seen one property, any two rows are same means you can make one complete row as 0, or any two columns are same means you can make any one complete column as 0, right? So if any two rows are identical, value of the determinant is 0, right? That is acceptable, fine. This is also one of the property. Okay, students, all the best. I think you are able to understand my teaching. I'm a teacher from Kola Saraswati School, Chennai. Thank you, students. Bye bye.